up to today is on Blackboard. That's what I did this weekend. Anyway, going back again for purposes of the recording. A complex fraction is a rational expression that has at least one fraction in the numerator, denominator, or both. Now, in terms of simplifying a complex fraction, you will notice if you look in the textbook that the book shows you two different ways to do it. I'm going to show you one of those two ways because in my mind it's far simpler than the second of the two ways. I'll just read to you the steps that the book tells you for the second way. After I read the steps and we've gone through the problem, if you want me to show you the second way, I will. The second way says, write equivalent expressions with common denominators, multiply, add, divide, multiply, divide, simplify, distribute. Those are the steps for the second way. I'll go through the first way, and like I said, if you want me to show you the second way, I'd be more than happy to. All right, so here, step number one is to find the LCD of all fractions. That's the first thing you want to do. Now, you might be thrown a little by the fact that I've got fraction, 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 not fraction. What? Hold a minute. A whole number. Yes. So it might be easier in terms of working on this problem to change this to a fraction. Of course, 1, we can just change to 1 over 1. Now it looks like it makes more sense because a lot of people get confused when they have a fraction and a non-fraction, what they're supposed to do. So by turning this into a fraction, it really makes it easier, I think, in terms of simplifying it. So step number one is to find the least common denominator. In other words, I'm going to look at each of my denominators and I'm going to find everything that's in common. So what do I have? I have an x here, and a y here, and a y here, and a 1. So what are the elements of the denominator?
1.
X and y, right? So I have x and y, and I have x and y. Now it has to be the same for all of them. So it's not that I have x and y here, and I might have something different here. If this were a z, for example, if this were x, this were y, and this were z, then my least common denominator would be x, y, z. It's going to be all the elements that make one common denominator. Okay? So here is x times y. Step number 2 is multiply each fraction by the least common denominator. In other words, I'm going to multiply 1 over x times xy plus x over y times xy over 1 over y times xy plus 1 times xy. And remember, you're multiplying by xy over 1. This is really xy over 1. This is really xy over 1. These are all really, and it might be easier, it might be simpler, or at least less confusing if I do that. Xy over 1, and then this is 1 over 1 times xy over 1. And again, the reason I think it might be easier to do that is because it can be confusing leaves me with just what? What's the only thing left in this? Just y. Y over 1 is just y. And what can I cancel out here? I can cancel out the y, and that leaves me with x times x, which is x squared. Because you're multiplying. You can only cancel top and bottom. Okay? Alright, how about over here? What can I cancel? I can cancel out the y here and the y here, leaving me with x. And here, I can't cancel anything. I don't have anything in the denominator. So it's going to be x plus x times y.
Why would it cancel the two x's?
What two x's?
On the denominator, the second.
They're not in the denominator. They're both in the numerator.
Oh,
You can only cancel a, you can only cancel a top and a bottom. You can't cancel a top and a top or a bottom and a bottom. And that's actually the end of the problem. We've simplified it as much as we can simplify.